All right, part two. Here we come, part two. All right. Using my last bit of energy for this video for the day. So we're going to let g of x in this video, or no, we're going to be solving for g of x just like before. So let g of x be a transformation of, but in this case, it's going to be of f of x equals 3x minus 2. All right, so instead of f of x equals x, we're going to be transforming this same function for all of these examples. All right, so let's get started. So we're going to start with f of x equals 3x minus 2. All right, we're going to do vertical shift up 2. So we're going to do vertical shift up 2. That's the same as translating vertical shift up 2. And what that means is we are going to add 2 to the entire function. So we're going to add 2. And then to the entire function, that means over here, I'm going to put the entire function in parentheses. And we are going to add 2 to it. All right. Our new function is going to be g of x. So do the parentheses really matter? No, they don't. So that's just going to be 3x minus 2 plus 2. Okay, well, that means g of x equals 3x because negative 2 plus 2 cancels out, and I just get g of x equals 3x. All right? Did not give myself enough room for this. Whatever. Is what it is. Too late now. All right. Horizontal shift right. So horizontal shift right 3 means we're going to subtract off a positive 3 on the inside. So we're going to start with f of x equals 3x minus 2. And we are going to subtract a positive 3 because that's what it means to go to the right. So we're going to subtract off a positive 3, right? If we go to the right, that means h is greater than 0. So 3 is greater than 0. So positive 3. So minus positive 3, which is the same as minus 3. But the point is you're subtracting a positive number. Okay, equals. Now it's happening to the inside here. It's happening to the inside. It's happening specifically to the variable itself. Well, do I have parentheses around this variable? I don't. I don't have parentheses around this variable. Well, why don't I create some? I can do that. Doesn't change anything. Totally fine for me to do. Which means I can now put parentheses here and do my x minus parentheses minus 2, and I can subtract off 2 to the variable itself, only to the variable, not to the whole function, right? Not to the whole function, but only to the variable itself. Okay, so our new function is g of x, and that equals, well, I need to distribute, so 3 times x is 3x, 3 times negative 2 is negative 6, and then we got our minus 2 on the outside. Well, need to combine like terms, and I'm going to get g of x equals 3x minus 8. All right. Awesome stuff. So if it happens on the inside, it needs to happen only on the inside. And if you don't have the inside of parentheses, then you better make some parentheses. All right, because what I mean by the inside, it means it's happening to the variable. Only the variable. It's not happening to the entire function. It's happening to that x. All right. All right. Next one. Reflection across the y-axis. So we're going to first off, we're going to start with f of x equals 3x minus 2. Okay, y-axis. Ooh, that's on the inside also. It's happening specifically to the variable only. So it's going to happen only to the variable. Okay, well, I don't have parentheses around the variable, so I need to put parentheses around the variable like I did in the last problem. So I'm going to have 3 parentheses minus 2, and I am also multiplying this variable by a negative. Make that a little more clear. All right, multiplying it by a negative. All right, so now our new function is g of x. Well, what's 3 times negative x? Oh, negative 3x. And then minus 2. There's our new function. G of x equals negative 3x minus 2. Awesome. You know what I'm going to do? I am going to actually there's our new function. Awesome stuff. New function. Okay. Got some more examples here. All right. Same function, f of x equals 3x minus 2. All right, so reflect across the x-axis. X-axis, we're going to multiply the entire function this time, not just the variable, but the entire function by a negative. So we get f of x equals the entire function in parentheses because we're multiplying the entire function by a negative. So multiplying the entire function by a negative. Our new function is going to be g of x. And then distribute the negative. So negative times positive 3x, negative 3x. Negative times negative 2 is a positive 2. Perfect. There's our new function. We just reflected this function about the x-axis, and now we got our new function g of x. Vertical shrink by 1/2. So vertical shrink and stretch means that we're going to multiply on the outside, and it's a shrink because we're multiplying by a fraction. So we're going to multiply the entire function. Better write down the function. We're going to multiply this entire function by 1/2. So we're going to get f of x and the entire function by 1/2. So times 1/2 times 1/2. So our new function is going to be g of x. All right, well, what's 1/2 times 3x? Well, that is 3 halves x. And what is 1/2 times negative 2? That is negative 1. So there is our new beautiful function. All right, new beautiful function. G of x equals 3 halves x minus 1. We shrunk it down. We made the slope a lot less. The slope was 3/1. Now the slope is 3/2, or 1.5. Smaller slope. Shrunk it, smashed it, compressed it. Okay. Now things are going to start getting fun. Now we're going to do 2 transformations all at once. 2 transformations all at once. Okay. So we're going to have f of x equals 3x minus 2. All right, vertical shift down what? Well, I gotta say down something. Let's just say down 2. So vertical shift down 2. That means we're gonna subtract 2, or we're gonna add a negative 2, which is subtract. So we're gonna subtract 2 off of the entire function. And a horizontal stretch by 1/2. Horizontal is on the inside, so we're gonna multiply on the inside to the variable, specifically to the variable, only the x, by 1/2. Okay, so let's write this out. So we're going to have f, and we're multiplying just the variable, just the input, by x, by 1/2. And then we are subtracting 2 off of the entire function. So what does this look like? Well, what it looks like, first off, is I don't have parentheses around my variable, so I need to put them. Because this is happening on the inside to the input only. So parentheses, 1/2. All right. Use my paper. All right, and we got that. And then we are minus 2. Okay, so I am at an issue here. I have an issue here. And my issue is I already did the 1/2. I'm multiplying the 1/2. I did this only to the variable, multiplying only to the variable, the 1/2. But now I need to subtract off 2 off of the entire function. So I need to put parentheses around the entire function and then subtract off 2. Right? So I put parentheses around the variable so that I could do something to the inside, but then I also had to put parentheses around the entire function, so that I could subtract something off of the entire function. Fun stuff. All right, so we now have g of x. And now we need to simplify the heck out of this stuff. So what is 3 times 1/2? Well, that's just 3 halves x. So I'm actually going to keep this parenthesis up, and then minus 2, and then minus 2. So I did one step. I did 3 times 1/2 x, which is just 3 halves x. Okay. Now, are these parentheses really necessary? No, they are not. So I can just drop the parentheses and have minus 2, minus 2. Okay, well now I need to combine like terms, and that would be g of x equals 3 halves x minus 4. That's where we stop. That's where we stop. All right, now some of you guys might skip steps. I get that. It's cool if you see how to skip steps, but I don't like to skip steps when I teach. So that's the long way. That is the long way to do that problem without skipping steps. All right, 3 more examples in this video, and we're calling it quits. I can only cover there's so many different variations of transformations. I mean, if you really wanted to, you could do there's like 10 different transformations, all to one thing, all at once. It'd be ridiculous. I'm not going to do that to any of my students ever, but you could. Okay, so we got f of x equals 3x minus 2. Reflect across the y-axis. That's going to happen to the inside. So reflect across the y-axis happens on the inside, specifically to the variable. So that means that I'm going to need to put parentheses around the variable. Vertical stretch by 5 means I'm going to multiply the entire function by 5. So we're going to have f of x. Ooh, see, I didn't leave room. We're going to have to fit it in there. We'll fit it in there. So we're multiplying the inside by a negative. That was my bad. And then we're going to multiply the entire function by 5. Oops. So equals the entire function, and then we need to put parentheses around just the variable. And now we have the entire function in parentheses, this entire original function inside parentheses, so we can multiply it all by 5. We also have parentheses around just the variable, and I need to multiply that by a negative so that I can do a y-axis reflection. All right. So this is just g of x. That's just g of x. Okay, so I'm going to simplify the inside first. So I'm going to leave the 5 on the outside. What is 3 times negative x? Well, that's just negative 3x. Okay, now we can distribute the 5. What's 5 times negative 3x? Okay, well, that's negative 15x. What's 5 times negative 2? Okay, well, that's negative 10. Done. All right. So again, it is really important. I mean, if you have separate colors, it might be helpful to do separate colors and maybe keep track of your colors and be like, okay, well, these are the parentheses here. Those green parentheses, right? Maybe if you have different colors, to use different colors. So I have parentheses around the entire function, but then I also have parentheses around just the variable, right? And what happens to just the variable happens on the inside of those ones. And then what happens to the entire function happens on the outside of those ones. Maybe a little bit. All right, 2 more examples. Now we're throwing in a key word here. I love this word. I don't know if I love this word, but we're throwing it in there. So we got the word then, and we're also going to have it here. Highlight it now. So what this means is you're going to have not two separate, how do I want to say that? You're going to transform it to g of x, and then you're also going to transform g of x into h of x. Okay, so you're going to have to do not necessarily is it two transformations, but you're going to have to do one transformation, simplify, and then another transformation, simplify. Okay, so we have f of x equals 3x minus 2. So the first thing we're going to do is a horizontal shift left 2. And when we do a horizontal shift left 2, that means we're going to subtract a negative 2. So we're going to have f of x minus equals, we need to put parentheses around the input because we're doing this specifically to the input. So 3 parentheses x minus, and then we still have our minus 2 out here. So we're subtracting off a negative 2, subtracting off a negative 2. All right. So this is the first transformation. We need to simplify this now. We need to change this into g of x. So g of x equals, okay, well, this would be, let's do two simplifications. So this would be 3 times x plus 2 minus 2. And then the next one would be g of x equals, let's distribute the 3. So 3 times x is 3x. 3 times 2 is plus 6. And then we have the minus 2 out here. Now let's simplify it one more time. And then we'll be ready to transform it the second time. So if we simplify it one more time, we're going to get g of x equals 3x plus 4. 6 minus 2 is positive 4. Okay. Now, then, so we did the first thing, and then horizontal shrink by 3. Now, horizontal shrink by 3 means we're going to multiply the inside by 3. So we're going to multiply just the input by 3. So what we're going to get here is we're going to get g of x, or g of 3 times x, equals 3 times 3 times x plus 4. And this is now going to become h of x because we have transformed it to be a whole new function. We transformed this one to be g of x. Now we've transformed this one to become h of x. Okay, well, what's 3 times 3x? 9x. There's the new function. Make that look more like a 9. There's the new function. Awesome. Perfect. Had to transform it twice. Yeah, is a lot of math? Yeah, it is. I shouldn't say it's a lot of math. It's not really a lot of math. But if you're just learning this, it might be more math than you are used to. I did not leave myself room for number 9. We're going to figure this out, though. I have to write a little bit smaller. So f of x equals 3x minus 2. All right, we are going to do two things, actually, and then another thing. So we are going to first do a vertical shift up 5 and right 2. So what we're going to have here is we're going to have f of x minus a positive 2. And then we are going to go up 5. So what this means is we're going to need parentheses around the input. But we're also going to need parentheses around the entire function. So 3 times x minus a positive 2 minus 2, and then plus 5 to the entire function. All right, plus 5 to the entire function. So this is now all going to be g of x. Fun stuff. It's all now g of x equals. I'm going to have to write tiny here. I think I'm going to try and fit this in. I'm going to do a little simplification step in between. This would be 3x minus 6 minus 2 and then plus 5. And then I think that gives me enough space to where I can then simplify this stuff, where I would then get parentheses don't matter, so I'm just going to drop the parentheses. So I would get 3x minus 6 minus 2 plus 5. It's a lot of stuff going on. I'm going to combine all these like terms, and I will get g of x equals 3x negative 8 plus 5 is negative 3. Okay. Whew. So I moved it to the right 2 units by subtracting 2 to the input, and then I moved it up. I moved the entire thing, the entire original function, right? The entire original function, which was 3x minus 2. Now it's 3x minus 2 because we also moved it to the right. But we did that. Now we need to then reflect across the x-axis. So I'm actually going to go to the left here, and I'm going to say g of x equals 3x minus 3. X-axis reflection means we're going to multiply the outside by a negative. We're going to multiply the whole thing by a negative. So negative g of x equals negative the entire function, 3x minus 3. And that will become h of x equals, okay, well, what's negative times positive 3x? Negative 3x. Okay, well, what's negative times negative 3? Oh, positive 3. That one was a lot quicker. A lot quicker for that one. Okay. Is this math pretty involved? Yes. Do you need to rewatch this video more than once? Maybe. Do you need to do these problems over and over again? Maybe. Do you need to ask your teacher for help? Possibly. If you do it step by step, if you keep track of putting parentheses around the variable when you need to do something specifically to the variable, and parentheses around the whole thing when you need to do something to the outside, you should be fine. Hopefully. All right. Enough doom and gloom about that and about this being difficult. I really, truly hope this video was helpful, especially if you are one of my students who are watching this. So thank you for watching. Give it a thumbs up if you found it helpful. Thank you.